Hello and welcome back to another episode of Math with Sohn. Today, we are going to be solving compound inequalities. Let's get into it. So a compound inequality is an inequality where you got something like negative 8 less than or equal to 3y minus 20 less than 52. So an inequality that is compound means you actually have two inequalities. You got your first one right here, and you got your next one right there. And you're just going to solve them both individually and separately, I might add. I would recommend doing one at a time. So negative 8 less than or equal to 3y minus 20, that one. We're going to solve that inequality. And then we're going to solve the other one. With the negative 8 covered up, we get 3y minus 20 less than 52. Let's solve them both and then graph it, of course, as always. Add 20 to both sides. If we add 20 and 20, you get 12 less than or equal to 3y. Divide by 3, 4 less than or equal to y. Hooray. And then we add 20 to this side, add 20 to this side. Wonder why I wrote a problem that has such a big number. That's 72. Divide by 3. 72 divided by 3 is 24. If you divide by a negative, make sure you flip your inequality symbol just like normal. We're going to graph both of those on a number line. 24 and 4. Not to scale at all. On the 24, it's a hollow circle, and it's going to be going to the left because it is pointing to the left, and smaller numbers than 24, y is less than 24. And on the other side, we have 4 is less than or equal to y, but if you don't like reading it that way, you're welcome to flip everything, and I mean everything. The y would flip, the inequality went from less than to greater than, and the 4 is now on the other side. But you can read it upside down, kind of. Y is greater than the 4. The mouth bites the bigger value. So y is greater than the 4. And that would be a filled in circle because it has the equal to. And it would go this way. These are called convergent answers, and they kind of go in between each other. And that would be our answer, where we have it in between it. And that makes sense because the value with our equation was in between two things as well. So that's our first one. Another example like this is sometimes they're not written with it being compounded like this. Sometimes they're written with an or and an and. So let's say we have something like this. We got 2x minus 3 greater than 15. Or 3 minus 7x less than 17. So let's see what that one looks like. They already separated it. We're just solving both of them. We're going to add 3 and 3. 2x is greater than 18 and x is greater than 9 because we divide by 2. And then here we subtract 3. We get negative 7x less than 14. If you divide by a negative, like we are right here, we're dividing an inequality by a negative, you have to flip your inequality symbol. Okay. Now, the question is, what's going on here? If we plot 9, we plot negative 2, and both of them have a hollow circle to the right of negative 2, and also to the right of 9. So what's the actual answer here? Because of the word or, that affects the problem. If it says or, that means that it could be negative 2 greater than that, or it could be greater than 9. It's one or the other, which means as long as it's one or the other, this negative 2 answer kind of gobbles up the 9. It's gobbling it. And we get the answer officially as x is greater than negative 2. That would be the actual answer because this answer encompasses and includes the other one. Now, if you change this to an and, if this was like magically switched to an and, what would change then? If we changed this to an and, that would mean that it would have to satisfy both things. If it has to satisfy both things, then how can it be greater than -2 and greater than 9? Well, you can't be greater than -2 and greater than 9 unless you're just greater than 9. Okay? So if it switched to and, the and solution would be the greater than 9 version because that one accomplished both all the time. So it's a little tricky. Another way of thinking about it, and a lot of times in like algebra 1, this is more algebra 2, it would be, are they going towards each other? And if they're going towards each other, that would be an and type of problem, versus if it's going away from each other, that would be an or type of problem. What I mean by that is and problems tend to look like this for algebra 1. This is algebra 1 mostly. Algebra 2 can have variations like we just had. Algebra 1 or problems tend to go away from each other. And that's okay. That's just a typical thing. All right? But this is a relatively short episode. It's not that complicated. I might have made it a little bit worse at the end, but this is a weird scenario specifically for Algebra 2 and maybe some Algebra 1 honors. It's a thinker question and something that you could imagine a real-world situation. You'd never want to have like a scenario where you have too many hot dogs and not enough hot dog buns, so you would at least buy a certain amount. So like one answer would encompass the other. That's how that would apply to the real world. I'm getting off on a tangent. Sorry for that. But until next time, stay positive. I will see everybody later. Bye.